Hello Gators, this is 2-2 Proving Lines Parallel. We are going to use the converse of the postulate that we had the last lesson. And I want you to notice that the words have switched. This is a converse. Now we're saying same side interior angles are supplementary, and the conclusion is that we are parallel. So here it is in a picture in if-then form. If you can see that these two types of angles, their same side interior angles, are supplementary, then we can say the lines are parallel. Let's take a look at this picture right here. I want you to notice that 80 and 100 are formed by line C, line B, and line A. They are on the interior, just like it says here. They are on the same side, and they add up to 180. So that means that A must be parallel to B. We don't know about C and D, but we know for sure about A and B. Let's take a look at this example. In this example, the lines that are making up these angles are this line, and this line. And we can see these are interior angles, and they are also on the same side, and they add up to 180. And because that happens, we do have parallel lines. These lines right here that the transversal is cutting. So we say that line C is parallel to D. All right, let's go ahead to our converse of a theorem we had before. Again, the if part is about corresponding angles being congruent, and we want to prove that the lines are parallel. So we are not starting with parallel, we're ending with parallel. So we have 1 and 2 are congruent, so that is given. I am going to change that into equality, so definition of congruent angles. I notice that angle 1 and angle 3 have to add up to 180 because linear pair angles add up to 180. We had a theorem that said that. All right, now I'm going to take angle 1 out. I'm going to take angle 1 out, and I'm going to substitute angle 2 in its place. So I'm going to write substitution. And now I have these two angles right here, this angle and this angle. I have them adding up to 180. So when that happens, the lines are parallel. So if same side interior angles are supplementary, then the two lines are parallel. And that was the postulate that we just talked about. All right, let's talk about the converse of another theorem. This time we're going to work with alternate interior angles that are congruent, and we want to prove that the lines are parallel. So we've got these angles 1 and 2 congruent, so that's given. We can say that 1 and 3 are congruent because those are vertical angles are congruent. Notice that angle 1 is here and angle 1 is here, so these two are by the transitive property of congruence. And 2 and 3 happen to be corresponding angles. That was the theorem we just finished. So anytime if corresponding angles are congruent, which that's what we have, then the two lines are parallel. All right, here is another converse. This time we're going to have alternate exterior angles congruent, and we want to prove we're going to get parallel lines. So we have the given, we have these alternate exterior angles congruent. We can say 1 and 3 are still congruent. Vertical angles are congruent. And since line 1 has angle 1, line 2 has angle 1, we can say 2 and 3 are congruent because of the transitive property of congruence. And 2 and 3 happen to be corresponding angles again. So we can say if corresponding angles are congruent, then the two lines are parallel. All right, so let's take a look at this picture and see if we can figure out which theorem to use. Find the parallel lines and give the theorem. These are the lines I need to be working with: C, D, and A, because they are the lines that make up those two angles. Now those two angles are called corresponding angles, and they happen to be congruent. So yes, I do have parallel lines, and they happen to be C and D. Let's take a look at these angles, and again I'm going to draw the lines that make them. So these lines make up those two angles, and I can see their alternate, and I can see their exterior. So these are alternate exterior angles, and they happen to be congruent. So yes, I get parallel lines, and the parallel lines are line A and line B. All right, I'm going to outline the lines that make this 75-degree angle and this 75-degree angle right here. And I want you to notice I have outlined 4 lines. And we can't have 4 lines. We can only have 3 lines, a transversal and 2 lines. So there are no parallel lines. We can't use any of our theorems. Let's take a look at this one. Again, I'm going to outline the lines that make the 100. And as soon as I do that, I'm going to try to figure out that name. It looks like they're facing the same direction, so that's corresponding angles. So yes, I do have parallel lines, and they happen to be A and B. Let's take a look at this, and I'm going to outline the lines that make those 2 angles. I'm only outlining 2 lines, not 3. In fact, these are called vertical angles. There is no theorem here about vertical angles making parallel lines. So there are no parallel lines. We don't have any because we don't have any angle information that would help us. All right, let's take a look at this proof. And let's see if we can't go through the steps that'll help us. All right. So we are being given, let's put it in color, we're being given that G is parallel to H. So let's go ahead and write that down. 1, G is parallel to H. Angle 1 is congruent to angle 2. Those are all given. Now, I have these parallel lines, and I have this transversal. And as soon as I see these parallel lines, I know something about 1 and 3. So I can say angle 1 is congruent to angle 3 because I've got parallel lines. If 2 lines are parallel, these angles are called corresponding. So these are corresponding angles are congruent. All right, and again, I'm noticing that angle 1 is here, angle 1 is here. So I can say angle 2 is congruent to angle 3, and that is the transitive property of congruence. And I'm going to get another color here now. Let me use green. I now have angle 2, so I'm going to outline the lines that make angle 2 and angle 3. So these green lines make angle 1 and angle 3. And these 2 angles are called corresponding angles. So these corresponding angles are going to give me parallel lines. So I can say, and the parallel lines are the P and the R. So P is parallel to R because if corresponding angles are congruent, see that's what these were corresponding angles, then the 2 lines are parallel. So I've actually used a property, I've used a theorem using parallel lines, and I've used a theorem using proving lines are parallel. All right, let's go ahead and find the slope. There is no graph, so you're just going to have to do it the old way, which is which with the formula y2 take away y1 over x2 take away x1. So this is 0 take away 8 all over negative 3 take away 5. So this is negative 8 over negative 8, and the answer is positive 1. So the slope is 1. All right, so remember we have just done this problem before, so we can say the slope is 1. We have just figured out the slope. Now I'd like to write the equation of the line, and remember the equation of the line and point slope looks like this. And I'm going to use my slope, which is 1, and I'm going to use this one, negative 3 here, and I'm going to use this as 0. I could have used the other one too, by the way. So this is going to be y, and I'm not going to say y equal to 0, and then I'm not even going to write a 1. I'll just write x, take away negative 3, and 2 negatives in a row make a positive, so you could just say this. And that's the end of the screencast.